Hi, today we're going to be solving equations that have radicals in them. Now, a couple points before we start, I want you to recall some basic rules, and I'll leave these up here and refer to them as I go, so a little bit less board space I'll have. That 4 to the second is 4 times 4 is positive 16, as it always has been. But recall that 4 to the 1/2 is the square root of 4, which is indeed 2, but it's also negative 2. So the square root of 4 is a plus or minus 2. That's going to come into play solving equations here. We're not just dealing with the principal square root. Furthermore, when we have a rational exponent, we can do the denominator first. It's usually easier that way. When you're calculating this, instead of doing 25 to the third power and then trying to take the square root of a large number, it's a little easier to take the square root of the 25 first and then raise it to the third power. And that's all you see being done here. Rewriting it as 25, the square root of 25. At 1/2 times 3 is 3/2. And that, of course, is 5 to the third power, which is 125, plus or minus. All right, let's begin. Our first objective is to get the variable that has the rational exponent isolated. I'm also going to write it in exponent form as I do so. So this will be 4x to the 1/2 power, and then add 1 to both sides, is equal to 4. And then we simply divide by 4 on both sides, just like you would solve a regular equation. These would cancel out. I have x to the 1/2 power is equal to 1. Now, here's where the basic idea about how to solve these equations comes into play. Instead of just thinking every time it's a square root, we square it, yes. But change your mindset on it. Multiply by the reciprocal of the exponent. So if I raise this power to another power, the 2/1 power, the reciprocal of 1/2, then I do the same thing to the other side. Now this, by the way, sometimes we can do something called gaining a root. I mean, gaining an answer that isn't part of the regular answer, an extraneous root. This could happen because I'm squaring it in, I'm adding it in here. So we end up with x is equal to 1 in this case. And they start out with a simple version where everything works out nice and easy. All right, there's the first one. All right, let's carry on. Next we shall try, I'm going to do 14 and jump just a couple, to skip around a little bit to give us some problems left to do when we meet each other tomorrow or whenever our class meets, depending on which class you're in. 14. We have the square root of x plus 2 minus 2 equals 0. Okay, this time we have a quantity under the radical. So x plus 2 to the 1/2 power, and then add 2 on both sides. And we would have x is equal to 2. And then we'll raise that power to a power using the reciprocal. And they start out with 1/2 and square roots, basically, because you're familiar with it. And then we'll change this fraction to any fraction we like, actually. 2/1, 2/1. And then this 1/2 times 2/1 just becomes x plus 2 to the first power is equal to 2 to the second. And then minus off 2 from both sides, and x equals 2. Now what we're going to do is we're going to check our answers here. I should have done that for the first one. I'll go back and plug the number in to show that it works. But let's do our check here, because like I said, you can actually end up getting extraneous solutions, and that will be in this section. Answers you get mathematically that actually don't make sense when you plug them back into the equation at hand. So we'll check. We'll plug in 2 back in for x. The square root of 2 plus 2, and then minus 2 equals 0. I'm simply plugging in for x. And then that's the square root of 4 minus 2 is equal to 0, which is 2 minus 2, which is 0. And that's basically how you check. Next. Now we won't run into extraneous solutions in the first set of problems. that'll occur in the second video where we start having extraneous solutions. So in this video, we really don't have to worry about it so much. We'll just try to concentrate on the technique, and then we'll worry about plugging back in to make sure it works as we go. At 18, I got x plus 5 to the 2/3 power equals 4. Notice I'm giving myself a little space when I write the problem down here. What I'm going to do is I'm going to need to insert the reciprocal 3/2. And this way, when I multiply it, 6/6, or 1 whole. And you do that to the other side as well. 3/2 on this side, 3/2 on this side. So over here, we just end up with x plus 5 to the 1st power. And here we have a choice how we're going to do this. And that's why I brought this up down here. We can do the denominator first, the square root of 4, which is plus or minus 2, and then raise that to the 3rd power. So essentially, I'm going to be doing it this way. That's the same as the 3/2 power. I'm just doing the denominator first. This is the square root of 4. So plus or minus 2 to the 3rd power. Notice the other side just stayed. I didn't mess with that as I already had it to the 1st power. Now I need a minus 5 off both sides. So this creates two equations, one with positive 8 and one with negative 8. Positive 8, negative 8. So minus 5, x equals 3, minus 5, and x is negative 13. So my two answers are 3 and negative 13. And then you simply make sure that you're not going to have any problems plugging negatives in. As my index here is odd, I would not have a problem plugging in the negative. It won't give any issue at all. So this would be our final answer. I'm looking at the clock, trying to make sure I keep us about 10 to 12 minutes and no longer. 3. This is problem number 20. Times x minus 2 to the 3/4 equals 24. You could pause the video now and try yourself. You divide by 3 first and then raise it to the reciprocal power and see what you end up with. What you're going to get is the following. Divide by 3 on both sides. X minus 2 to the 3/4. I'll leave a little bit of space because I'm going to need to raise it to the 4/3, is equal to 8. Then we raise this using the reciprocal. Okay, on this side we just have x minus 2, and that's 12/12, or the 1st power, which is just x minus 2. And on this side, we can do the cube root of 8 first. We'll do the denominator first. That's 2. And then raise that 2 to the 4th power. So I'm basically doing the following. 8 to the 1/3 to the 4th. That's this, which is 2 to the 4th, which is 16. And then we add 2 to both sides. And we get 18 for x. That's number 20. I'm at 9 minutes. Not bad. Okay, and 22. We would have x plus 1. Is it 3/2? Minus 2. Equals 25. And again, you could try this again now. You want to isolate the term that has the rational exponent. Add 2 to both sides. Leave a little bit of space because I'm going to insert a power. I will raise that to the reciprocal, 3/2. So 2 over 3. This is 6 over 6, so it just becomes x plus 1 is equal to, and that's a cube root, so that'll be 3 to the second, which is 9, minus 1, and x is equal to 8. 8 plus 1 is 9. The square root of 9 is 3. 3 to the third is 27. 27 minus 2 is 25. And then there's one problem where they have a formula. So just want to address that real quick. It's the last problem on this video. Would be the following. We have 1 over 6 d to the third pi is equal to 9,000. This is number 24. And if you're wondering where I got the 9,000 from in the formula, look at problem number 24. They tell you that it equals 9,000 as a volume. Okay, what we want to do is isolate the variable that has the exponent. So we'll times by 6 on both sides is the first objective. And I took some liberties to actually do a little bit of calculation here. So what I'm doing, you would just do on your calculator. I did it on my phone calculator. These 6's cancel out, and I get d to the third power times pi is equal to 54 and 3 zeros. Divide by pi, divide by pi. And I use 3.14159 for this. And I got d to the third is equal to 17,188.75. And then how to calculate this? Well, you would need to take the cube root. If it's 3 over 1, you make it 1 over 3. Then you do the same thing to the other side. And no longer are you stuck only be able to solve if it was x squared and taking square root. You can do any reciprocal of any power now. So in this case, d would equal to, and then you would raise this to the 1/3 power. That would be 25.8, which would be the diameter here. I hope this was a little bit helpful, and I'll see you guys all when I see you in class. Thanks.